All right, so I went through your Google Forms and I took a look at all the questions that you guys said that you had over Unit 9, and I did my best to compile kind of a secondary review where I'm hopefully answering all of your questions. There were some that were too vague for me to answer. For example, like I don't understand all of parametrics. Okay, what I need you to do if that's you, and again, not more than one person saying this, so I'm not singling anybody out here, but if that's you, I need you to then go back, look at those lessons, listen to those lessons, retry the homework and notes, look at the answer keys, and come at me with some specific questions. Otherwise, again, I have office hours. After I saw some of those questions, I was really expecting to see some of you guys at office hours, and there only ended up being 2 people there. So if you're really concerned about these questions, I need to see you guys during office hours where I can answer questions live time. All right, so let's get started. All right, so one of the main questions that I got over and over again was, how do I identify the conic given little information? I'm not sure what you meant by little information, if this is what you meant here, where you're given just the general form and you're asked to then identify the conic. If you are given general form and you're asked to identify the conic, I was expecting you to complete the square. So when you're given the general form, like we have here for all of these, I was expecting you to complete the square to then identify the conic. There are other ways to do it. There are faster ways to do it. If you really understand what an ellipse, a hyperbola, parabola look like, you can very quickly circle, you can very quickly understand which one's which. But again, I was expecting you guys to do what we had done in class and just complete the square. So I'm going to do an example here. I'm going to purposely choose one that's a parabola, and then I'll choose one that's not a parabola. So I'm going to do number 2. So that's 2y squared, group the y's, minus 12y. Move everything that's not a y over to the other side. And really quickly, if you're looking at this, like, how did she know that was a parabola? Because there's only one squared term. One squared term is going to be a parabola. So before I can complete the square, I have to have 2 factored out. I can't complete the square with a leading coefficient other than 1. So we have 6 divided by 2 is 3. 3 squared is 9. So we're going to add 9. But I didn't actually add 9. I added 2 times 9, so 18. So to balance this equation, I need to make sure I add 18 to the right side. So my left side becomes 2 times the quantity y minus 3 squared equals x plus 4. And then standard form, rectangular form of a parabola does not have a coefficient on the squared term. It has the coefficient on the non-squared term. So we're going to divide both sides by 2. And there we go. Very clear that this is a parabola. But again, all these 1 through 6 was asking is classify the conic. So you, from looking at this, knowing there's one squared term, I know it's not going to be, or it's going to be a parabola. I just wanted to make sure to show the complete the square process one more time. All right, so number 5, actually, you know what, no, I'm not gonna do number 5. I'm gonna do, I guess, number 4. Yeah. All right, so number 4, we have, so now I'm doing number 4. X squared plus 4y squared equals 4. They're already perfect squares. It's already x squared, y squared, so I don't need to complete the square here. I just need to put it in standard form. So I divide everything by 4, and we get x squared plus, or sorry, x squared over 4 plus y squared over 1 equals 1. So I know that this is an ellipse. Now, number 3 looks like an ellipse, but it's not. If we divide by 3, we end up getting x squared plus y squared equals 5, which is a circle. Difference between an ellipse and a circle are the denominators of our x squared, y squared term. If they're the same, it's a circle. If they're different, it's an ellipse. And then these other ones, 5 is going to be a parabola because there's only one squared term, and then 1 and 6 are going to end up being hyperbolas because of the subtraction. All right, another common question that I think I got, again, you guys were very vague, so there were a lot of questions that said writing parametric equations, and I was like, okay, just writing them given the rectangular form, writing them given context, but like, what do you mean writing the parametric? So I'm guessing that this is what's meant is given the rectangular form, find the parametric equation. So I'm going to give you an example of both a linear and a parabola. So let's say, for example, we're given a linear. I'm going to just say y equals negative 1/2 x plus 5, and we want to write the parametric equation. So there are lots and lots of different ways to do this. I am a fan of substitution. So one way that you can do substitution is just like this. Let's say x is equal to t. Well, if x is equal to t, then y is negative 1/2 t plus 5. Done. Parametric equations. Another way is if you want to actually make the line go in the same like direction, down 1, right 2, down 1, right 2, like we have here, because this one's going to actually go right 1, down 1/2, right 1, down 1/2. This equation here, looking at those slopes. So if you wanted to actually from here pull apart the x versus the y, you have to think about how does x change with respect to time, how does y change with respect to time. So remember, slope is change in y over change in x. So if we're pulling apart x and y, we have y is increasing 2 every second, starting at, that's the y-intercept. I'm sorry, I think I said y, I mean x. X is increasing 2 every second, and that's the y-intercept, which means our point is 0.5, so starting at 0. And for y, we have y is decreasing by 1 every second, because again, change in y is the numerator of our slope, but starting at 5, because the y-intercept. So there's another potential equation. There are infinitely many correct potential equations. These are 2 examples. For parabola, again, my preference is to just do a substitution. So like we did up top with let x equals t, so y equals negative 1/2 t plus 5, that's totally fine. For a parabola, it's the same exact thing. I suggest you do a substitution. So how you do a substitution here is you set what is being squared equal to t. So y plus 2 is equal to t, which then means t squared is equal to negative 12 times x minus 1. So again, set what's squared equal to t and then substitute t in. And then you just simplify. So our 2 equations are y equals t minus 2 and negative 1/12 t squared equals x minus 1. So x is negative 1/12 t squared plus 1. So our parametric equations are x equals negative 1/12 t squared plus 1, and y equals t minus 2. All right, someone specifically asked a question on 12. Love that, because I can now actually answer your question very specifically. So write the equation of the conic in standard rectangular form and parametric form and graphic. All right, so our center is at negative 2, 1. Negative 2, 1. There's our center. Our focus is at 4. 1, 2, 3, 4, 1. And our vertex is at 2, 1. So that means that this is a hyperbola because our center is to the left and our focus is to the right. And remember, always opens towards the focus. And there's no mention of a directrix or anything, so it's not a parabola. So this is definitely a hyperbola. So hyperbola opening to the right, which means that x is positive. So we have x plus 2 squared minus y minus 1 squared equals 1. And now I just need to figure out the numbers underneath. So center to vertex is a distance of 1, 2, 3, 4, which means the number underneath x squared is 16, because our distance that we moved right left is 4 right, 4 left, 4 squared, 16. And then to find the number underneath y squared, we have to use our equation for our focus, because I don't know up down motion, but I do know my focus. So the distance between my center and my focus is 1, 2, 3, 4, 5, 6. So using that a squared plus b squared equals c squared formula, we can find b squared. So 16 plus b squared equals 36. So b squared is equal to 20. And so we have that as our rectangular equation. Type of conic, this is a hyperbola. And again, if you're like, how the heck did I know it was a hyperbola? It is because of the fact that of where the center, vertex, and focus was. So our graph always opens towards the focus. So since in this case it was opening towards the focus and away from the center, it had to be a hyperbola. And then this says put it in parametric form. Because of the fact that we're only teaching 2 lessons a week instead of 4 to 5 lessons a week, we had to cut that out of the curriculum. So you guys unfortunately are not going to get a chance to learn how to parameterize the rest of the conics, which is unfortunate. It's a really great connection, but it's not 100% necessary for calculus, so we cut it. All right, this is another question, is how do I specifically do problems like these? This is similar to one that you guys had to do on your the review that I gave, not exactly the same. So I am going to show you this example as like a brand new example. All right. A glob of peanut butter and a glob of chocolate travel so that their positions at time t in seconds are given by these sets of parametric equations. So these are linear because no t is being squared. Make a graph for the glob of the peanut butter and a glob of the chocolate from t equals 0 to t equals 5. A lot of questions of how do I graph a parametric equation? Dude, how do you graph anything? Table of values, right? So for the peanut butter, which I will do in purple, and we want time equals 0 to 5. So 0, 1, 2, 3, 4, 5. All right, so x equation is -6 plus 30t, and our y equation is -7 plus 2t. So we have -6, -3, 0, 3, 6, 9. and then -7 plus 2t, so we have -7. Sorry, just double checking. Okay, cool. Plus 2t, so -5, -3, -1, 1, 3. All right, so we graph those points, and we have -6, -7. And that's at t equals 0. And then we have -3, -5. That's at t equals 1. And then we have 0, -3. That's at t equals 2. And then we have 3, 1, 3, -1, 6, 1, and 9, 6, 7, 8, 9, 3. And that's at t equals 5. That's at t equals 4. That's at t equals 3. And that's at t equals 1. Our direction of travel is this direction. So we need arrows showing that's the direction of travel. All right. According to where, now we need to graph the other one. So let's have the other one be blue. And we have t x, which is 1 plus t, and y, which is 3 minus 2t, and 0, 1, 2, 3, 4, 5. All right, so we have 1, 2, 3, 4, 5, 6. And then here we have 3, 1, -1, -3, -5, -7. All right, so we graph that, and we have 1, 3, 2, 1, 3, -1, 4, -3, 5, -5, and 6, -7. So again, the direction of our travel, this direction. So draw some arrows to show direction, and then we have to draw in some times to show speed. So we have time equals 0, 1, 2, 3, 4, and 5. All right, so A, check, done. B, according to the graph, where do their paths cross? So this is just looking at the graph, where do they appear to cross? And it looks like both of them, let me get my highlighter, both of them cross the point 3, -1. Will the peanut butter meet the chocolate? No, because they're at the same location at different times. So peanut butter is there at 3 seconds, where chocolate's there at 2 seconds. Now, if you're like, yeah, but it's going to leave, you know, a skid mark, and so they will meet. All right, that's not what this question's implying. It's just saying like the glob itself is kind of rolling, but I get that. I get where you're coming from. But what, again, we're really asking is, are they at the same place at the same time? And yes, they're at the same place, but no, they're not there at the same time. It's 1 second difference. All right, so hopefully that makes it clear on how to graph linear parametric equations. And then there was another question on a parabola parametric equation, a word problem. So I'm going to do one like this. All right, so Jay Cutler throws a football with an initial velocity of 80 feet per second. It's 20 degrees angle with the horizontal towards Devin Hester. The ball leaves Cutler's hand at an initial height of 6 feet. What is the ball's maximum height nearest 10th? Okay, so we need to come up with our equations. So this is the one that, again, I said you just have to memorize. projectile motion for a parametric equation. So we have x equals initial velocity, which was 80 feet per second, times cosine theta, so cosine 27 t, and y equals negative 16 t squared plus initial velocity, so 80 sine of 27 t, and then plus the initial height, which was 6 feet. So there are a set of parametric equations. All right, so when is the ball at a maximum height nearest 10th? What is the maximum height nearest foot? So again, make sure in your mode that parametrics is selected and simultaneously graphed is selected. Go to your y equals, and also you want to make sure that your calculator is in degrees, in your mode as well. So go to your y equals, type this in, 80 cosine of 27. Make sure that you end the parentheses around 27 before you type in the variable, okay? And then negative 16 t squared plus 80 sine of 27 t plus 6. And I'm gonna really quickly go on to my face. So we have the two equations typed in. X1 is 80 cosine 27t, and y1 is negative 16t squared plus 80 sine 27, again, end parenthesis t, and then plus 6. So now when I'm gonna go into my window, if you're not able to see these, it's probably because you don't have your window set up to see it. So t again is time. I'm gonna check from when time is 0 to 10, 0 to 10 seconds. And my t step is 0.13. Now for parametric equations, it graphs points. It doesn't actually graph a line. So I'm graphing a point every 0.13 seconds, which you want it to be fairly often so you get a good actual shape. So T minimum, X min, X max. X is our distance. So a football field is 100 yards, it's 300 feet. I mean, plus there's end zones. But I have mine going from 0 to 500, which should be way more than enough. And then our Y min, Y max, I'm again not 100% sure how high a football will go, but I would not think it's going to be more than 100. So I have mine going from negative 10 to 100. Again, because I don't think the football will go any higher than that. So I'm going to hit graph and just kind of see what happens. See, my window is way too big, but that's okay. All right. So now let me go back to my screen. Okay, so now when we go to answer A, where is the ball at a maximum height? I'm gonna hit trace, and then I'm just gonna scroll until eventually it looks like I'm at the highest. So right now I'm at y equals 25.8, 26.5, 26.6, and there we go. Then it starts to get smaller, 26.1. So it said round to the nearest foot, so 26 feet, maybe 27 feet, depending again on your T-step, you might have gotten something that was a little bit more accurate, but it should be right around 26, 27 feet. Oh, maximum height nearest 10th. So actually, so what did I say? 26.6 was the highest that I got. What is the maximum height? What is, oh, when is the ball? Sorry, I need to read my own questions. All right, erase. Start over. Okay, when is the ball at a maximum height? So I have that at t equals 1 point, said round to the nearest tenth, so 1.2 seconds. And maximum height is at 20 round to the nearest foot. So mine's 26.6, so it would round to 27 feet. And again, if you had a different T-step or a different window, you could potentially get something very similar to this, but just a little off, and that's okay. B, Devin Hester is 150 feet away from color. When Hester jumps up to catch the ball, his hands are 9 feet above the ground. How much higher is the ball at that time? So now let's scroll over to where X is 150, and you might not be able to use your calculator for this. Like, for example, I cannot use my calculator for this. So you can always solve algebraically. So for B, we know that X is equal to 150. So that means that 150 is 80 cosine 27 t. And again, if you're like, how did we know X was 150? Because Devin Hester is 150 feet away. That's horizontal distance. So that means that t is 150 over 80 cosine 27. So I can substitute this in here and actually solve for y. So negative 16, and then I'm going to type this in, 150 divided by cosine of 27 squared plus 80 sine of 27 times 150 divided by 80 cosine 27. Sorry, I was missing a parenthesis earlier. Okay, and then plus 6. And we end up getting our answer of 11. I got 11.5754. So nearest foot. So the ball is currently 11.6. So we'll say 12 feet in the air because it said nearest foot. And he's 9 feet tall, so 3 feet taller. And if you want to look at that pictorially, we have Devin Hester's 9 feet. The ball at this point is 12 feet, 9 feet. So there's a 3-foot difference. And he's not 9 feet tall when he jumps. And then how long is the ball in the air to the nearest tenth? Again, you can go to your graph, hit trace. Let's take a look. So I have my height is 2.7 at the time 2.3. And then I have my height is negative at the time 2.5. So this is about 2.4 seconds. Because again, you're looking at where height is 0. That'll be when it hits the ground. All right, another type of question is how do I write a parametric equation when you're given half of it? So again, this one, don't make it any harder than it needs to be. You already know half the equation, use it. So if I know x is equal to 1 plus 2t and y is equal to negative 3x plus 5, then that means that y is equal to negative 3 times 1 plus 2t. So negative 3 minus 6t plus 5. So that's negative 6t plus 2. And then same thing here. If I know that y equals 8 minus 9t, And I know that y equals negative 3x plus 5. That means 8 minus 9t is equal to negative 3x plus 5. So subtract 5, 3 minus 9t equals negative 3x. So x is equal to 3t minus 1, or negative 1 plus 3t. All right, and then there was another question about writing equations in rectangular form if we're given a focus and a directrix. So again, you have to graph. If our focus is at 2, 0, and our directrix is the line x equals 0, write the equation of the parabola. So your vertex is always directly in between your focus and your directrix. That's the definition of a parabola. It's the set of all points that are the same distance away from your focus and your directrix. So that means that our vertex is right there at 1, 0. Also, parabolas always open towards the focus and away from the directrix. So I know that we're going to have y squared because it's opening to the right or to the left. So we have y minus 0 squared equals something times x minus 1. So this here is 4p. P is the distance between your center and your focus, or your center and directrix. So our p value is 1, so this is 4. I know it's positive because it's to the right. If this is opening to the left, it'd be negative 4. So simplify, and we get y squared equals 4 times x minus 1. Hope that helps. All right, and then there was another question about, and actually I'm not 100% sure if there was a question on this. Again, it was one of those very vague. I'm having a hard time writing rectangular from parametric, and I'm like, what kind, from word problem, from what? So I put one on here just in case. So when you're going from parametric to rectangular, all you're doing is you're eliminating the parameter. So you're doing it with substitution. So we saw here for a linear that we did it with substitution that way. And actually this one was going backwards. So here with substitution, we're going to take this equation here, solve it for t. So we have t equals y minus 4. And then that means that x is equal to negative 112 times y minus 4 squared minus 1. And then you just put it in the form. So this is a parabola because we have one thing being squared. So we need to solve for the quantity y minus 4 squared. So we add 1. And then multiply by negative 12. And then rewrite it with the y minus 4 squared on the left side, and there is our equation in rectangular form. So again, when you are going from parametric to rectangular, all you do is just eliminate the parameter, and you eliminate the parameter with a substitution. So if you're like, how do I do that with lines? I don't think I put an example in. I didn't. That was the last one we had. So I can really quickly just make something up. So x equals negative 2t plus 5, and y equals, I don't know, 1/2 t minus 1. All right, so it's completely up to you if you want to use the x equation to solve for t or the y equation to solve for t. I will always use the x equation because we want our answer to be y equals. So here we have x minus 5 equals negative 2t, and this is not going to work out nicely because I just made it up right now off the top of my head without working through it first. So I, again, subtracted 5. Now I divide by 2. So I have t equals negative 1/2 x plus 5/2. Substitute that in. So we have y equals 1/2 times negative 1/2 x plus 5/2, and then minus 1. So we get y equals negative 1/4 x plus 5/4 minus 1. So we end up getting y equals negative 1/4 x, that'd be plus 1/4. All right, so hopefully I answered all of your questions. I am going to, in addition to this video, I have a small little optional review posted with an answer key that is just up to you if you'd like a little bit more practice before taking the test. And then I have the test posted as well. The test is due Tuesday at by midnight. So we do have one more office hour before the test if you would like to ask any questions before taking it. Now, I'm going to write all of this in Classroom, but I'll say it now too. Your test is through Google Form. You have to take it on a Chromebook, and you have to take it in one sitting. So you cannot take it, exit out of it, take it again, exit out of it. I get a notification every time that you exit out of it. Also, it locks your screen. So when you're in it, that's the only thing that you can be in. So I want you to know that ahead of time, that before you sit down to take it, you're sitting down to take it. You're knowing, okay, I've studied, I'm good, I'm ready, I'm going to take this test. There isn't any pausing it, looking up an answer, going back to it. None of that. There's no taking it multiple times like our quizzes and our Google Forms. Nope, it's a test. It's one-time final. So be very ready for it. Have your notes out, have your notes ready, and make sure that you can commit the appropriate amount of time to taking it, okay? It should take you, it's a test, should take you about 50 minutes, all right? All right, well, stay safe, stay sane, and please, 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 please stay distant. Bye, everybody. Bye.